So please make sure you've watched the other unit circle video that I also posted on the same date, and watch that one before you watch this one. This is where we talk about big angles and negative angles. One thing I want you to notice about the unit circle is the direction of rotation. And so if we have a positive angle, oops, let me get my little pen out. If you have a positive angle, so if your angle is greater than 0, that means that you are rotating counterclockwise. It's a little arrow there. Okay, but if your angle is less than 0, you're rotating the opposite direction, rotating clockwise. So for some people, if they see a negative angle, they just go clockwise the same amount of distance that the positive angle would have gone counterclockwise. That's one strategy. The other big idea is that you can always add or subtract a full circle and end up at the same place. That strategy works both for big angles and for negative angles. If you add or if you subtract enough full circles, you will eventually get back to one of the angles that you can look up on the unit circle. So let's do an example, and I'm going to do it first with degrees because I think that's a little more intuitive for a lot of my students, but then we'll practice it with radians. So for example, let's say I have a question that asks me to do the cosine of negative 120 degrees. One strategy is to rotate clockwise 120 degrees. So if I rotate clockwise, this would be 90 degrees, and this would be rotating 120 degrees. I want you to notice that the counterclockwise rotation will always be directly above the clockwise rotation. Okay? So a little trick is just look at the positive version of the angle and go to the other half. Go up or down until you reach the other point. The cosine value at that is the x value is negative 1/2. You also may notice that negative 120 degrees is in the same location as 240 degrees. And why does that make sense? If you take negative 120 degrees and you add a full circle, 360 degrees, you end up with 240 degrees. So the other strategy for dealing with negative angles is to add or subtract full circles until you get to an angle that you can look up on the unit circle. Let's do another one. It's a negative angle. I'm going to use radians on this one. It's nothing to be intimidated by. It's just that we're using radians instead. So here we go. Let's look at the secant of negative 3 pi over 4. Okay, strategy 1 is to rotate 3 pi over 4 in the clockwise direction. That gets you right there. Remember that you can always rotate counterclockwise to 3 pi over 4 and then take that trip to the other side of the circle, like that. Secant is equal to 1 over the cosine, and the cosine is the x value. So here I have 1 over negative root 2 over 2. It really just flips it over, so you can say it's negative 2 over root 2. Because if you divide by a fraction, it's the same as multiplying by the reciprocal. The other strategy, instead of doing it visually by rotating, is to notice that we can add a full circle. And a full circle in radians is 2 pi. But when you're adding fractions, you need a common denominator. So my denominator of 4 means I multiply the numerator by 4, and it becomes 8 pi. Negative 3 plus 8 means we actually are at 5 pi over 4, which matches with the angle that's right there on the unit circle. So what is the idea? What's the takeaway with negative angles? Two different strategies. One is you rotate clockwise to get there. And I showed you kind of two different ways to rotate clockwise. One is just to count the correct number of dots to match with the top. The other is just to rotate the positive angle and then drop down or up to the other side of the circle. The second strategy to deal with negative angles is to add a full circle and then look up that equivalent angle. And then the last thing is talking about big angles. So I'm going to give a big angle example with degrees and then a big angle example with radians. So let's say that I was asked to figure out the cotangent of, let's say it's 750 degrees. 750 degrees is not on the unit circle, but I can always just subtract 360 degrees until I get an angle that is on the unit circle. 360 will get us to the same location. So if I do 750 and take away 360, that becomes 390. And then if I take away another 360, that becomes 30. So the cotangent of 750 degrees is the same as the cotangent of 30 degrees. Cotangent of 30 degrees is, it's flipped over tangent. So tangent is y over x, so cotangent is x over y. So square root of 3 over 2, that's the x value, divided by the y value. Remember that you can multiply by the reciprocal. So square root of 3 over 2 times 2 over 1. Boom, cancels, you get square root of 3. For one last example here, I'm going to do, let's just do sine of a very large angle in radians. Same strategy. Let's say that I have the sine of 35 pi over 4. I can subtract 2 pi as many times as I want. So if I take 35 pi over 4 and I subtract 2 pi, common denominator means I'm actually subtracting 8 from the numerator every time. So I can just kind of write this out as a string. All I'm doing is subtracting 8 pi over 4 because that's a full circle. So 35 minus 8 gives me 27 pi over 4. That's too big. Take away 8 more. Gives me 19 pi over 4. Take away 8 more. 11 pi over 4. Take away 8 more. 3 pi over 4. Now we can look it up right there. And once we look it up, the sign says the y value, so we get square root of 2 over 2. If you want more explanation on anything in this video or the other videos, please ask. I'm more than happy to make more videos like this. And that's all for this one.